Thanks. And hopefully it's really rough going up after Jake. That was just awesome and a little intimidating. But I want to try and keep this as interactive as possible. So at any point during the presentation, if you have any questions, random suggestions, or anything else, just throw up your hand and we'll have a little bit of a two-way. I know Steve said I could probably talk for 8 hours. 90 minutes is a little intimidating at that. So hopefully I won't rush through it, and hopefully we'll get everything that you want covered. I'm actually not going to be talking too much about the tooling. I'm hoping to go over, so like Steve said, I've been doing this, it's a little scary to admit, for like 15 years, I think, when dial-up was still the primary method of web browsing. And we've learned a lot of things over that time, and I'm hoping to take you through a lot of that so you don't have to repeat a lot of the things that we've done and we've seen. The slides, hopefully right after this, I'm going to put them up. They'll both be linked to the session as well as up on SlideShare. So don't worry if you miss a link or something else like that. They're all linked in the slides. So don't worry about keeping notes. So I'm going to take you through as if we're running a fictional e-commerce site, Shop Denial. They do archaeology tools. Sort of named it after a big river because that's what e-commerce sites do. But we're going to take you through sort of the evolution of what we did as we launched this e-commerce site. And I did register the name, so don't go squatting on it and trying to sell spam or anything else. We did the typical, this is what the system architecture looks like when we deployed it. We've got your load balancers. We're expecting loads and loads of traffic. We've got app servers carved off. They're serving the application-specific stuff. We've got separate static file servers. We've got databases out the wazoo. We've got databases for products, for reviews, for tracking customers, all that kind of stuff. We even went and we put in a Solr full-text search because you want to be able to search for your products, right? And we have separate stash of product images off there. So that's a pretty typical stack. What I'm going through here, it's not going to be specific to e-commerce. Pretty much any website of reasonable scale is going to look something like this, publishing or CMS or whatever. And so, we were tracking as we're building it, and we care about performance, so we started looking at the page load times. And this is us just sort of browsing around in the office, testing things out. And the them is some other large e-commerce site, right? Pretty much anyone who's got real traffic. And we're getting ready to launch, and we're like, holy crap, this looks really bad. 12 seconds, what's going on? We do the typical, you look at the waterfalls. And I know Steve's mantra, it's 80+% on the front end, 97% sometimes on the front end, and very little time is spent on the back end. That's usually because dev teams have optimized the back ends because it's really painful. And you actually do end up seeing a fair number of waterfalls like this. The one on the left is what ours looked like, where the back end time, that huge green bar at the beginning, it's all back end time. So the browser's doing nothing, and you're sitting there, you're waiting for the app server to do its thing and then serve it out. And the app server team was all excited. It's like, woohoo, we can query all of these databases and return content in 4 seconds. It's like, really? 4 seconds? We don't have that much time to deliver the whole page. When you can't make it fast, what do? You cache it. So we go ahead and we throw in cache servers everywhere. So now we've got memcache sitting in front of the databases, right? So everything's fast as long as it's been accessed before. So we're reading things out of memory. We put varnish in front of the static servers so that we can serve the static files really, really quickly. And we were all excited. The architecture's growing a little bit. It's getting a little more complicated, but for good reasons. We can scale now. We can serve things really quickly. And woohoo, that's the kind of graph you like to see, right? Load times dropped significantly. They're not quite as fast as the competition yet, but that's a huge win for us. We got rid of the back end time. Until the boss goes on a trip. So we sell archaeology tools. So he went to Egypt, and now all of a sudden he's calling us and he's going, hey, how come the website sucks? It's really, really slow. And we're back at the office going, what the hell are you talking about? It's fast. We're browsing it all day long. It's great. And so our customer base, we've got customers all over, pretty much wherever anything interesting happened archaeology related. South America, Africa, India, some China as well. And, these aren't sort of the places where they have great internet connections, but we don't expect it to be too bad. And then we have a whole bunch of traffic from the US as well, because people want to buy all their tools before they go on their trips, right? And the red star, that's where we are. We're in New York. We're hosting everything from a data center that's locally, because we like to be able to go touch and hug our servers. Everyone likes to do that, right? So we come up with a testing plan. We're going to go and we're going to test from 14 different locations globally. We want to be able to see what the performance is from where our users are. And testing's expensive. We've got a couple million products in the inventory. We can't test all of them. We're going to pick 3 representative pages. That's kind of typically what you do. Okay, everyone tests the landing page, right? Okay, I'm going to compare myself to Amazon.com's landing page. Well, okay, so we'll also test a product search result page, and we'll test a product listing page. And that's sort of the 3 main templates we have. There's shopping carts and all that kind of stuff, but we're going to kind of pretend those don't exist right now. They have their own optimization issues. And the testing service we're going to use, they primarily work off of one browser, so we're going to go ahead and do our testing with IE. And we're only going to test first view, but we're going to test every 5 minutes, because we want to have enough samples that we have representative data. We can look and we can tell if something goes awry, we get an alert, and we can go yell at someone and page someone and go fix it, right? And we also want to be able to average out the noise and make sure we get stable results. So we think this is a reasonably good testing plan. It's kind of what you see. Woohoo! 12,000 tests per day. It's not too bad. Testing's not too expensive. And these work out to be really good for marketing, because those are cleared cache, no cookies, so they're unique visitors. And woohoo! Everyone likes unique visitors, right? So we're going to go throw 12,000 new unique visitors at our pages, too, while we're at it. Of course, until we have to go back and we fix our analytics tracking to filter it out. There's a whole bunch of products. Most of them are vendors here, so stop by. They've got up on the vendor exhibits. And I'm sure I probably missed 1 or 2, and I apologize for that. These are the ones I knew off the top of my head that can do synthetic testing from global locations. Most of them have commercial services. Web page test is free. I have to push web page test as well. But they all largely do the same thing. They'll drive a browser. They'll test it for you. They'll give you performance data, usually on load, first byte times, things like that. And this is what our graphs look like. It was a mess, right? So the bottom one is the competitor, and somehow the legend is gone. But these are by the different locations. So the red one is, actually these are just us, not the competitors. So the blue line was us in New York City, and the testing's from New York City. And then it just sort of crept upward. The other lines were from testing in the US, and then it was Europe, and then the rest of the global locations. And it wasn't too hard to figure out that the further away you got from the server, the slower it got. Right? And you're not sort of new to this. Latency sucks. And we could see it in the waterfalls. Everything was taking longer. So from the furthest location, everything was taking 400 milliseconds round trip to get back. And we were serving everything from New York. It's the speed of light through fiber and all that kind of stuff. Usually India to the US, 250 milliseconds, give or take. Australia is in the same ballpark. Europe to New York's not too bad, 100 milliseconds, give or take. Europe to the West Coast, double that. So if you're going to be serving a lot of US traffic, or US and Europe traffic, East Coast better than West. Go East Coast. So you know what? We like caching. Let's edge cache all the things. So we're going to serve everything from close to the users, get rid of that latency, right? You want to basically get rid of all the green bars as much as you can in the waterfall, deliver all the content. So we pull up the maps. These are the CDN maps. So actually, most of these are CDN maps. The top 4 are CDN maps. The bottom one, there's one CDN that has so many pops, they don't really show you the network map. So I pulled up a Google map of all the McDonald's locations, and I'm pretty sure it's a toss-up if Akamai has more pops or if McDonald's has more locations. I'm not entirely sure which is it. And the rest are largely very similar. US, Europe, Asia, They have most of the geographies covered. But you know what? We're still in early funding. We're going to go ahead and blow all of our VC money. So we're going to go with the one. If you remember, we're doing archaeology tools. So we've got all these really weird places. We've got Egypt in Africa. We've got South America, sort of a lot of the places where you don't normally see a lot of edge nodes. So we really wanted to have something where we had edge nodes right next to all of our customers. So we went ahead, we sucked it up. And now we have a CDN test plan where we're going to we're going to evaluate, right? We test. We want to make sure we're getting our money's worth out of it. We're going to test the McDonald's of the CDNs, or, well, that's not fair. They do a lot of good things. So we're going to test Akamai against the two of the other CDN vendors that we liked. We're going to run it for 2 weeks, and we're going to compare it against each other, but we're also going to compare it against running locally. How much faster would it be if everything was actually run from the edges? And how much are we getting from it versus no CDN, right? So, okay, woo, marketing loves us now. 36,000 unique visitors a day. Okay, they hate us because we're completely killing all of their actual numbers. And if you ever happen to see this, so I get pinged every now and then from web page tests because people will say, what the hell's going on? Someone's testing my site, and all of a sudden my analytics are out of whack because we're driving a bunch of unique visitors. So just ping me. There are ways to filter it out from your analytics. And these are what the test results look like. So down right at the bottom is what it looked like. So the blue line is what it looks like served locally. And way up at the top is what it looked like with no CDN. And sort of in the middle, we have a striation. You've got sort of the yellow line is the edge nodes that are right there, right next to all of the test pops. And then right above that, you've got the other two CDNs. And it's sort of, at this point, you're making a cost decision. OK, is that extra little bit in this testing at least worth it? And we're like, you know what? We're going to go ahead and we're going to do it. And now so we went ahead with the edge nodes that are everywhere. And now we're going to compare ourselves to the competition again, right? We want to see, OK, are we there yet? How do we compare against the other e-commerce sites? Also, so 20 page loads a day. We wanted representative data, but we don't care about the alerting, the 5-minute response windows, but we still want enough data that we can say, okay, roughly this is how they're performing that given day. We're still testing 3 representative pages, and so the volume's a lot less. And we're really close at this point, right? We're like hugging the other provider. And the other provider's been doing this for 10 years. They've got global infrastructure. They've got stuff pushed everywhere. So we're kind of happy with this. Except the users are still complaining. They're going, what the hell are you doing? It's still slow. I don't feel it. So this is sort of where we go, OK, we're going to see the users are complaining. What is it like for the actual users? So, RUM, it's the latest and greatest. Also, these are all, at least all of the ones that I'm aware of. The RUM providers. I'm sure there are several others. Most of the synthetic testing companies also have a RUM solution. These are beacons you drop on your page, JavaScript. They'll beacon back from the real users what the performance of the pages were like. And there's a whole bunch of open source beacon solutions as well. Steve wrote one, Episodes. Philip, if he's around, wrote one, Boomerang, which was sort of the basis for the SOSTA solution. And then there's also, I saw there was one that was just announced like 2 days ago on Google Plus or something, where he's got one that's already integrated with Graphite. So you just drop the JavaScript on your page, and voila, everything starts showing up in your Graphite graphs. So we've got analytics. We've got basically, OK, so on the page, we've got third-party stuff. We've got ads. We've got like buttons. We've got +1 widgets. And we've got analytics out the wazoo, right? You need the ComScore beacon because that's what you're going to tell the market your numbers are. You've got the Omniture beacon because that's what you're tracking for your tracking. You've got the analytics beacon because someone decided they wanted to do that. You've got the chart beacon because you've got the real time that you're tracking and you want to do as you're selling stuff. And then you've also got the retargeting beacons that you're putting on your page so that you can say, hey, this guy's interested in photography equipment. This guy's interested in cars. So we've got beacons out the wazoo. So, we've already got RUM. We just go in, we hop into analytics, and we see what it looks like. And we see, hey, our server response time, 1.3 seconds. Our Average page load times, 5 seconds. Our testing doesn't look anything like that. Our testing was telling us the pages are loading in 1 second. What's going on? This is telling us our first byte times are even slower than that. So, it's time to figure out what's going on. Instrument everything. So, if you haven't already seen it, Etsy, they're probably doing several talks here as well. They've got an awesome blog, Code as Craft, where they talk about how they all do all of their instrumentation. They've released a bunch of the stuff that they've done for it, so you can sort of just throw it all together. But it effectively comes down to dump everything in your access logs, shove your access logs into Graphite and StatsD, and you can do percentiles and things like that. And you can see how long different operations take on your back end. There are also commercial providers for a lot of this stuff. There's a whole space, application performance monitoring. There's an M involved in there somewhere. APM. I'm kind of fond of New Relic. I run it on my stuff. Most of these you just drop in. You go to their site, and you can see exactly where your time is being spent on the back end. So very large return on investment there. And what we ended up seeing, so we plotted things out, right? We get our times, and the response times look like this. There's a huge bucket where it's 0, and then we have sort of your normal distribution, and then kind of a long tail as it goes out for the larger bucket. And these times are kind of insane. The further right you get, it's up into the seconds, right? You're up over 1 second, 1.5 seconds. You kind of figured, I'm sure most of you have seen this before, the 0 bucket were cache hits. The other ones, not so much. We're going back, we're having to hit the databases, we're running queries. But our testing still looks great, right? Everything's coming back really fast. The problem comes out with our test plan is we're testing 3 representative pages frequently, 14 minutes apart, or from 14 locations, 5 minutes apart. So roughly every minute we're testing any one of these pages 2 or 3 times. They're pretty much guaranteed to be in cache somewhere, everywhere, actually. And apparently I should log out of AIM. Yeah, pro tip. There we go. Yeah. Especially the people that IM me, some of my old coworkers are questionable content, but that's okay. And yeah, so we sort of revisited the testing plan and go, okay, if any of you have been at Velocity previously, you know what to do, right? SSDs. Everyone, go buy an SSD, right? Huge props to Artur. I'm not sure if he's here for this conference. Hopefully they are, but he completely nailed it. So now, instead of caching everything, so we're still caching everything. We've got our caches there. But we also went ahead and we just throw SSDs at everything. So the databases, in theory, now are really fast for doing everything. Product images didn't need it so much, but long tail can fetch everything really quickly. That's what they're good at. They scale very well. So now we've got kind of a beast growing. But the devs didn't have to do anything. They didn't have to change any code. They didn't have to tune any of the databases. They probably should have, but we like to fix things for them without having to involve them. So woohoo! Our server response times look like this now. And it's still not quite as nice as when everything was coming out of RAM and when everything was cached. But we've got a really good, 80, 95% of the responses are all being served under 400 milliseconds. So we're pretty happy with that. And the general target, shoot for under 100 milliseconds is good, but we've got kind of a rich app, so we're like, okay, we're done here, we'll move on. So, woohoo, our server response times now come in at 0.3 of a second. Not too bad for globally, given global latencies and everything else. Everything's still coming back to New York, so we're like, okay, we can live with that. Our page load times, not so much. It's still 4.5 seconds. It's like, what's going on? So our synthetic testing was still telling us 1 second. And this, it comes down into a lot of things. And probably the biggest one that you're going to bump into is, so when we did our synthetic testing, we're running 36,000 tests a day, right? Those are expensive, depending on what you decide to do. And most of the monitoring companies have sort of a menu you can pick from, right? You've got we'll test just your base page. That's really, really cheap. It's a wget scheduled on cron, basically, and we'll tell you how long that takes. Then they've got the synthetic fake browser. It's not a real browser. It kind of pretends and mostly does kind of things that normal browsers do. It'll pull the HTML, and then it'll scan the HTML, and anything it finds in there that looks like it might be an URL, it'll fetch those, and it'll kind of try and do it over 6 connections at a time, that kind of thing. But we can run a whole bunch of those in parallel, so it's really cheap for us to do. So that's, half a cent per test kind of thing. There's the real browser testing. It's a little more expensive, but we still run it in our data centers. We run several on a machine. We can scale those reasonably well. That's significantly more expensive, but that's the one we picked because we wanted to do real browser testing, but it's still run in the data centers. Then they also have the last mile testing. These are run on real consumer lines, real DSL, real cable lines, real latencies. Those were absurdly expensive, at the time at least, so we went, not so much. We can't justify that. So we went with the backbone testing. The unfortunate thing with the backbone testing, and I don't hope it's not a secret anymore in the industry, but it's one of those things where it's bitten us a bunch of times in the ass, is that the latency from the backbone testing to the CDNs is 0. It's like really close to 0, because the data centers that the testing is done from, sometimes the CDNs know where those are. And anytime you're holding someone to benchmark, you will optimize for that benchmark, right? So the CDN pops get put right next to the test nodes, and all of a sudden you've got giggy connections plus 0 latency to your edges. So anything that's cached in the edges looks really, really fast in testing, not so much for the users that don't live in the data center. If you're selling to the users that are in the data center, props, go for it. The other problem we had was our long tail images. So we're serving, it's pretty much the same problem we had with the 3 representative pages. The edge caches for the CDNs have a very similar problem with the mem caches and everything else, is they're serving images for billions of sites. We're serving 1 million plus images. Most of them don't get hit that frequently, so they can't be hot in all of the edges all of the time. So the real users start hitting long tail image problems where they're not actually in the edge caches. And so if you haven't already seen this probably comes up at least once every Velocity or so. A couple of years ago, Mike Belshie ran a test. He was at Google. Basically, does bandwidth matter more? Does latency matter more? How do things stack out? And the bandwidth ended up being, after you get past 2 megabits or so, it's kind of doesn't really matter for web performance. At that point, you're serving the bits as fast as you can, and latency is your big bottleneck. Latency, on the other hand, had a completely linear correlation all the way down to 0. So the more you can reduce the latency, the faster things get. And our synthetic testing was way over there, right? Super fast connections, almost no latency. Our end users, well, once again, not so much. I don't think I have stats in the deck, but usually you'll be very hard-pressed to see end-user latencies anywhere under 100 milliseconds, give or take. And that's not just 3G and mobile or anything. Last-mile latencies, 28 milliseconds, give or take, is about as fast as you generally see. That's for cable. DSL is closer to 45, 50 milliseconds. If they're in an office, and if you're primarily serving offices that have really good backbone connections and stuff like that, then you'll start seeing lower latencies than that. But for the most part, 100 milliseconds to an edge is probably about where you should expect. Mobile, significantly worse. Even LTE, we're seeing latencies in the 100 millisecond give or take range. Theoretically, it should be closer to 25. 3G latencies, they're up in the 300 to 600 millisecond range. So you start talking numbers that look a lot like people are on the other side of the planet. And hopefully no one here has to live with a satellite connection, but satellite internet are measured in seconds, like 1.5 second round trip times. So what we ended up doing, we had the problem with the images always in the cache. So we changed our testing plan. So we're going to be running from last mile instead of backbone. We're going to be testing random search results in listing pages so that we can test the long tail of data. and browsers, we're no longer just testing desktop. We're also testing mobile. And on mobile, it's absolutely critical to test on a real device. There are a whole bunch of testing. Even web page test has a run Chrome, but emulate, pretend it's a mobile device. It'll do okay. It'll show you what the content's coming down. But the processors on mobile devices are so bad. You really can't emulate that very well. Running on a real physical device, even if it's not on a real network, running on a real physical device is just a scary thing, and you really have to do it. There's no better way. There's really no substitute for doing it. The thing you want to watch out for a little bit is you might get sold a little bit on running, do you run on a real 3G connection or an emulated connection? I'm a little bit split on that. I could probably be convinced one way or the other. But the problem with running on a real 3G connection is it's noisy. And when you're running synthetic testing, you kind of want stable results. You want to know if it's your content that caused a problem or your servers that caused a problem. You don't really care that someone was running a microwave and cooking popcorn at the time and causing all sorts of issues. So with a synthetic traffic-shaped connection, you can get the behavior of mobile and still have a reliable connection. If you're trying to, what you lose is you don't get things like radio wake-up times. So if you haven't read it yet, and I think Ilya might be doing it part of his talk, High Performance Browser Networking, highly recommended book. O'Reilly probably has a bunch of them upstairs. The mobile radios are kind of a scary thing as well, where they can take several seconds to wake up after they've gone to sleep, and they go to sleep really quickly. So like between pages while you're browsing, they can go to sleep. And that's the kind of thing you can't really test unless you're on an actual device, on an actual network. So if you care for optimizing about the radio states and that kind of stuff, you also have to test on a real 3G network. And so this is what our results look like. So we're still doing, we reran the CDN evaluation, this time with the new testing plan. This time we're running the test from the last mile. And no CDN still sucks completely. And running local, although running local and running any of the 3 other CDNs, the striations started to disappear. And this largely comes from the fact that when we did our first test, the CDN edge nodes for one of the CDNs was sitting directly next to all of the test nodes. And the other CDNs generally had regional pops. When you have last mile latencies, the latencies between the regional pop and the ISP is on the order of like 10 milliseconds, whereas you have the 100 milliseconds for the last mile. So it's kind of washed out in the noise. And all of a sudden, having a pop directly next to the user, maybe it doesn't matter so much. Maybe it does. It's kind of in the noise, at least in our testing. So at this point, we decided maybe we don't need to spend that much. But it's really important if you're doing an A/B evaluation and you're evaluating these kinds of things that you do the testing from the end user perspective, because otherwise you're going to end up making decisions based on the wrong data, right? You're optimizing things for the tests, not for the users. So we ended up having a problem, right? So the measured load times are still slower than the bosses wanted. So we've got, like I mentioned, we've got a whole bunch of stuff on there that we do for business reasons. We've got ads, even though we're selling stuff. We've also got ads for other stuff that we don't sell. We've got sharing widgets because you want to be able to tell everyone, hey, look at this really cool shovel. It digs better than everything else. And retargeting, we make all sorts of money on that kind of stuff. And we had 4 different analytics providers. And all of them, we've been going to Velocity for years at this point, so all of them are doing best practices. We've asynced all the things. We've done as good as we can. And, so what we did is we managed to convince everyone, okay, let's try a test where we strip all that out. We're serving nothing but our content. No more ads, no more analytics. Well, we kept one analytic because you kind of want to be able to know what's going on still. But we stripped everything else out. We've still got the server-side counts, but no ads, nothing else. And look at that. Page load times dropped in half. That's awesome. Well, not so much because we're not making any money anymore on all that stuff. But the other thing that sort of popped up and that was a huge problem was the user feedback we got was that it wasn't significantly faster. They were like, things still kind of feel the same. We like that there aren't any ads on the pages anymore, but we didn't get like all sorts of feedback that things are going really well. One thing we did get was, so the one analytics beacon that we kept, we moved it to be after on load, so it doesn't impact any of our tests and our performance any. And we noticed an enormous drop in the volume of analytics that we were getting. So we're like, oh crap, our users are all gone. What happened? They loved the ads, right? That was the problem. Because clearly everyone loves ads. Well, the problem was, and we've seen this several times, is the analytics beacons it's not really the beacon's problem. Users tend to fall off the longer it takes for things to load. And having the analytics beacon load after everything had loaded, they just weren't firing a whole bunch of times. So the further up in the page that you have your analytics beacon, the more likely you are to actually get the impression counts. So the analytics team is always telling us, no, we need this up at the head. And the dev teams are going, no, we need this out of the way. We need this at the bottom of the page. And it's one of those trade-offs because the further down in the page you do it, the more drop-off you get in the amount of counts that you get for your analytics. And if it's used for business reporting, they tend to care about that. So not to give it away too much, but so the problem we had was we're measuring the on-load time, right? So the on-load time, it's a good technical measurement for the browser. It's technically when everything that was in the HTML needed to be fetched was fetched. The user really doesn't care, right? The user doesn't see any of the retargeting pixels. The user doesn't see any of the analytics. They see some of the ads, although the ads we had, they're loading all asynchronously in iframes. They weren't actually interfering with the content, which is why they didn't notice that things weren't getting significantly faster. The on-load time wasn't getting any. The on-load got a lot faster, but the user content was loading about the same. So we have one of the things that we came up with to try and better measure the user experience, and we actually have a whole talk on, there's 3 different proposals for stuff in this space tomorrow. We have going beyond on-load, measuring the user experience. So the speed index is the one that we do in web page test, and it's only available in web page test, unfortunately, where it tries to measure the user experience and like how quickly does the above-the-fold content load for the user. And we went ahead and we redid the evaluation with and without a third party. And so the on-load time, so the left chart's the on-load times. And the on-load times, huge difference between having the third-party content and not having the third-party content. However, the speed index there was negligible. It was really small. And the only reason there was any impact on the speed indexes at all is there was some contention for bandwidth when it was downloading ads versus our content. But we had, like, all of the scripts for the ads, all of the scripts for the beacons were already async. They weren't blocking the browser. It was free to go ahead and push those off. And this isn't, like, theoretical. I've actually been working with people that stripped all of their ads off of their pages to make their page load times faster. And they didn't actually make the user experience faster. They just threw away money, basically, because their testing said the on-load time, we're optimizing for the on-load time. I'm going to hold you dev team responsible for the on-load time. I'm going to hold you ops team responsible for the on-load time. The ops team tended to get pissed because they'd get paged that the performance tracking went all wide, and they'd look at it and go, it was an ad. I can't do anything about ads. Why are you paging me? But also stripping all of that stuff off didn't help the business any, and it didn't help the performance any. You know, one of the big problems, it's only available in synthetic testing. But you know what? It's code. We can fix this, right? So what we ended up doing was we attached on-load handlers to all of our images on the pages, or various things that we care about. And now all of a sudden we can track when various different things happened. Once again, thanks to Steve, we have the user timing spec in the W3C performance. And there's a performance.mark where you can mark an interesting point in time for something that happens. Lock that. And basically, every time an image loaded, we marked a AFT dot. AFT is an acronym for above the fold time. And so we did AFT dot like leaderboard loaded, AFT dot blah. And then at the onload for the page, we pull all of the marks that we recorded, and we basically just do a substring. Anything that started with AFT, when's the last one of those that happened? So now we have a way of tracking the AFT, the above the fold time for when did all of the images above the fold load for the user? We can report that back, and that's our user experience metric that we want to track. There's a bunch of ways that you can do this. You can roll your own. If you've already got all of the Logster, Graphite, and all that kind of stuff integration, you just send a beacon back to your server, various timings that you want. They're just encoded as query params, and you pull those out. Great thing about them when you send them back as a beacon, the user agent string, the IP address that it came from, so you know geographically where the user was, and all of the performance metrics are all in one line of your access log. And you can feed it into the rest of your performance pipeline. So you go ahead and scrape your access logs, statsd, and all of a sudden, woohoo, profit. You've got your percentile distribution for your real user performance timing. Or you can use one of the commercial solutions. Google Analytics, there's a push method for track timing, where you can push user timing metrics, and you can push custom variables. So in this case, what we do is we push a custom variable for AFT, and we can track the above the fold time. And we can correlate it with the business metrics. Same thing for Boomerang and SOASTA's MPulse, which is Boomerang-based, is you can push custom metrics as well. I think I have more slides on this. I really like, as far as RUM tools goes, I really like SOASTA's visualization, and they've got a whole bunch of percentiles and stuff already plotted out for you. It's kind of what they do, so they do it very well. But one of the things you really do is you really do want to be able to correlate that with your business metrics. So it's a little bit of a shame that a lot of the analytics providers don't provide a way to get performance data along with your page views. So if any of you are customers, and I hope a lot of you are customers of analytics providers, ask the Omnitures and the ComScores of the world to allow you to push performance data so you can correlate both of them together. So we went ahead. This is actually live data. This data comes from Web Page Test itself, unfortunately, not the e-commerce site, because we didn't get enough traffic on the fake shopdenial.com to be able to generate anything. But the above the fold time versus the page load times, these are real stats. Even at the median, there's an enormous difference. The above the fold completes in under a second. The page load times are on the order of 2.5 seconds. And it falls off as you go up the percentiles. It's insane. The above the fold time, I'm not terribly pleased with a 4-second above the fold time for the 95th percentile, but it's not bad compared to the 11 seconds that the page load time is, or the 26 seconds that the 98th percentile falls off for the page load time. So if you're optimizing for the page load time, there's a good chance you're not optimizing for the user experience, even if you are tracking it through RUM. The long tail on the third-party analytics and everything else, even in Web Page Test, I ended up seeing a lot of cases where an analytics beacon is pushing out your on-load time. And it's like, it's not really user experience. Your on-load time got slower, but there's nothing you really can or should do about it. And don't strip it off, because you're not helping anyone out by doing that. So you also get, and hopefully some of the other synthetic tools start doing this as well, if you instrument things into user timings, Web Page Test will pull those out for you and expose them as separate timing events. So you get it both in your RUM and in your synthetic testing. You can get the above the fold time. You can get the time for any specific event that you mark. And if you haven't used Web Page Test before, well, shame on you. But there's also an API, if you're not aware, where you can automate it. You can schedule it to cron, and all of the individual timings are exposed through the API. The UI only exposes, actually the UI exposes them all as well. Although once you get above 3 or 4, the UI is probably not designed to handle it well.